Hello everyone, this is Alireza. Today we will work on our conversion utilities. The purpose of this class is to convert different type of variables to byte array and then reconvert any byte array to different type of variables. I may not use it at the start in this project, but if you think about streaming data on the network, then byte arrays are the easiest way of streaming any sort of data on any type of socket handling process on network. So we want a private, if it works, IntelliSense static UTF-8 encoding, and we call it an encoder. Okay, now we say public static byte array get bytes, and the first thing we want is a bool. So we convert a bool to a byte array, and if bit converter dot is little Indian, and is little Indian is a flag that will happen in some operating systems. Some of them are little Indian, some of them are not little Indians. So if it's little Indian, we return the bit converter dot get bytes of the B. Okay, otherwise we want a byte array calling bytes equals to bit converter dot get bytes of V, but because it's not little Indian, we want to reverse it. So we say array array dot reverse the bytes, and then we return the bytes. Okay, so non-little Indians are in reverse order of little Indians. Basically, this will repeat times and times again. So another one would be to get a byte, and we here don't care about little Indians. We just simply return the conversion of the byte to a bit array. The next one is an int. So again, the order is the same. So basically we are just getting different type of objects, at least if they are simple stuff. For color and others, we need to handle it differently. Actually, now that I think about it, I will go with object, and I check if object, if V is bool or V is int or V is float, because they are the same. We will handle it like this. Okay, else if V is byte, we will handle it like this. Boom. And we say else if V is string, we need to handle it differently. And at the end, I will return null, because if we hit it here, then we didn't do anything. So for the string, we say if encoder equals to null, we want to instantiate it. So encoder equals to new UTF encoding, and you know, I can just cut it, paste it here implicitly, so I know that it's not null anyway, but just for the sake of the completeness. Then we say if v equals to null, then we say and here I need a string, so string s equals to typecast nothing yet. So if v is null, then we say s equals to string.empty. Okay, and then we say else s equals to typecast to string of v. After that, we return the encoder dot get bytes of the v, and let me disable my VPN. That won't bother me time and time again. Not v, sorry, the s, the string that we got. Okay. After that, we say else if v is color in Unity engine. We want a color, we call it c equals to typecast to color, the v. After that, we say byte array buffer1, or I could say buffer r for red, equals to bit converter dot get bytes of c.r. Okay, Control C, Control V. This is G. This is B, and finally this is A. And after that, we take if not bit converter dot is a little Indian. And am I missing something here? No, that's correct. So if we are not a little Indian, we want to reverse those arrays. So array dot reverse the buffer R, G, B, and A. Okay. After that, we make a list of byte. We call it list equals to new list of byte. And I will take this guy outside of everything because I will use it time and time again. So here we say, wait, that. So we say list equals to new list. So we are starting from a new list. Then we say list dot add range of buffer R. Then list dot add range of buffer G. Then come on, list dot add range of buffer B, and finally list dot add range of buffer A. Okay, And finally, we return list.toArray. Okay, so this was for color. And these else statements are redundant because we use returns, and anytime we success, we will return, so we don't need else's. Now, same thing will happen if the v is a rect. So we typecast rect. We want the x component, the y component, the width component, and the height component. Okay? And we can change the names. X, y, and I shouldn't do it here. So x, y, width, and height. There we go. The rest is the same. Now, if we have a vector 2, it's almost identical. So if v is a vector 2, then we typecast to vector 2, and we just have the x and y. Okay? You can guess that the vector 3 should be fairly simple. Vector 3, and here we have the z, so z, and we have z, and we don't have this guy. Then we have vector 4, and finally quaternion. So vector 4, and this will be again z, this will be w, the z component, and the w component. Copy this one, and final paste for quaternion. Okay, so it's quaternion, quaternion, and the rest is the same, basically. Okay, now at the same time I was thinking about can we convert something like I don't know, animation curve into byte array. Well, basically you should be able to. And what are the errors? We need to typecast it to bool now, because we are using objects. And here, oh, see, ouch. Control C, Control V. Here is only bool. This is the int. Oh. And this is the float. Okay, and we typecast this time to byte, and the rest should be okay. Yeah. The only thing we have here, replace if statement with respective branch. Okay, this will work. And what else do we have here? V is string. Okay, var s1. I tend to use IntelliSense as much as I can, and when it tells me that, hey, this is safer, then well, I will do it. Why not? So I will, move the string check at the end. Boom. Okay. So if it's not null, otherwise, of course, we sent in null, so we return null. Okay. So, as I was saying, I was thinking about having animation curves, but let's take a look what we have in animation curves. If I close this method now, I will make a private animation curve and call it A. Now, what's your problem? Static. Okay. Anytime, anywhere, A dot keys, all keys defined in the animation curve, and it's keyframe array. Okay. So if I say this guy is a keyframe, let's see what keyframes has. Okay, so keyframe has value and time. Tangent mode, well, guess what? It's an int. Out tangent, it's a float. So in tangent is a float. So we should be able to convert these guys to bytes, because we already have it's a float, this guy should be a float, so we have only one integer and 4 floats, and we already are converting them to bytes. But the question, how many keyframes we have? So if I make a structure on our byte array like this, an int for the number of arrays that we have, then for each array we would have a float, and an int and a float. Okay, so basically I am defining one keyframe here, and I don't know, we know that these guys are 32 bits, all of them. So this is 32 bits, this is 32 bits, this is 32 bits, and this is 32 bits. So for each one, 1, 2, 3, 4, 5, let me get my calculator. Windows 10, please help. Calc. User account. Okay. Okay, so let's see. 5 multiplied by 32 equals to 160 bits. Okay. So the first 32 bit will indicate the array size. Then each 160 bits will define a keyframe. And for constructing an animation curve, these keyframes are all you need. But we will take a look inside this guy later. Let me finish my code first. and you'll see if we can handle it in maybe another episode. So to do convert an animation curve to byte array. Okay, and basically we have this part done. Not done, but that. So we have an array of these guys. Okay, now that we have our get byte arrays, we want to be able to get different type of values from byte array. So public static bool to bool, and what we want is byte array, and we call it buffer. Okay, now here we say if not bit converter dot is little endian, we say array dot reverse the buffer. After that we return the bit converter dot to boolean our buffer, and you see that it asks for starting index, and it's of course 0. Okay, now let's get this guy copied, and it will return a byte. Yeah, a byte, and we call it to byte, and here to well, we don't really need to do this, because a byte array and a byte, we can say buffer of 0. Okay, and then we start our other conversions. So it will return a color to color. So if we are not Indians, we want to reset the buffer, and you see that it asks for an index of 0 and then the length of 4 bytes. Okay, and that is our basically our value. This is from 4 and 4 bytes. That's our G value. Then another 4, and this is our B value, and finally another 4, that is our A value. Okay, then we say float R equals to bit converter dot to single. We can use you know, we can't use int. Single is equivalent of float. As you can see, the return type is float. So to single a value, not value, of buffer, and the starting index here is 0. Then we have our G value. The starting index is 4. Our B value, the starting index is 8, and finally our A value, that the starting index is 12. Okay, then we finally return new color of R, G, B, and A. Okay, now before color, I will get this guy, and we say to float or int first. So to int, and for int, of course, we want to int 32 of the buffer, and return type should be int. Then we want the float. Okay, and well, to single of that. So we have our color now. After the color, we want our rect. So Control C, Control V. It will return a rect, and we call it to rect. So the first part is the same. This will be X, Y, W, and H. And we return an erect with X, Y, W, and H. Then we want our vector 2. So we just have 2 of these for vector 2. And the return type is vector 2. So we return new vector 2 of X and Y. Then we have vector 3. To vector 3. It doesn't have this component. This is called Z, and new vector 3 of X, Y, and Z. Of course, we have vector 4. So vector 4 and to vector 4. Z on W and new vector 4 X, Y, Z on W. After vector 4, we have quaternion. To quaternion. Z and W. New quaternion. X, Y, Z, and W. And what else do we have? Only remaining is string. So it will return a string to string. And if I would want to go with Visual Studio's naming convention, I should have a 64 there, but meh. So the whole thing is changed. We here say if buffer that length equals to 0, then we return an empty string. Otherwise, we say if encoder equals to null. If we lost the encoder, encoder equals to new encoder. After that, we return our encoder dot get get string of the buffer with the index of 0, and the length is our buffer dot length. Okay. And of course, I need another to do here. Add ability to get an animation curve from byte array. And that is our converter utilities. Basically, let me stop it. I think I can handle it. So we say if the V is animation curve, First, we say animation curve, and we call it curve equals to typecast to animation curve of B. Come on, this happens a lot recently. Okay, and then we want the size of array, so we say int array size equals to and the curve dot keys dot length. Okay, then we want keyframe array, and we call keys equals to curve dot keys. Okay, now we want a byte array, and let's make our list of byte. We call it list, and we instantiate it equals to new list of byte array. Oh, we have it. I forgot it. Okay, so list equals to new list of byte array. Then basically we want to convert this first int to a byte array, and we already have it. So list dot add range of our array, or get bytes of our array size. So we can totally call ourselves recursively this once. Now, for each inside our keys var key, we will have different things. If we look, we have key dot value, so we call it, and it was a float, I think, dot value. Yeah, it's a float, so we say float value equals to that. Then we have key dot in tangent, and it's again a float, so float in tangent equals to key dot in tangent. Then we have key dot out tangent, and that is again a float, so float out tangent equals to key dot out tangent. Then we have key dot tangent mode, and it returns an int, so int mode equals to key dot tangent mode. And finally we have key dot time, and it's a float, so float time equals to key dot time. Now we want to add to this list, so we say and list dot add range, or get bytes of our value, then get bytes of our in tangent, get bytes of our out tangent, then get bytes of our mode, and finally get bytes of our time. Okay, before anything we should check if v equals to null, then we return null. So if we send in a null and remove if statement, did we check it at the top? Basically no. So here we check if v equals to null, then return null, so we don't fall into any of these guys later. Okay, now at the end we already added all the keys, so we just need to return our list dot to array, and we converted our animation curve into a byte array, okay? But how we can get it back, and what is this problem, is use ASCII var animation curve. Okay, so how to get it back is another story. Let me see. Public static animation curve to to animation curve a byte array of buffer, and we say animation curve, and at the end we return the curve, so we don't have any errors there. And yeah, I know, initial value is to null first. Then we say, before anything, we say if buffer.length equals to 0, return null. After that, well, we know that the first elements that we got is our, oh wait, no, basically, okay, the first elements that we have is the integer. So we say a byte array the array size buffer equals to how to get the first elements. Let's make a private class. So private static, it returns a generic array. No, I said generic array of, and we call it sub array of type T, and this T array data int index and int length. What we want to call is type of T array. We say result equals to new T array of the length. Then we want to say array that copy, yeah, why not, data comma index comma result comma 0 comma length, and finally we return the result. Come on, return the result. Now if I call it here equals to sub array of, oh, there we go, this array of buffer comma the starting index is 0 and 32 bits. Will this work? Sure, why not? So after that we say int array size equals to int of array size buffer. So we got our array size. Then we want for int I is less than array size. Okay, now we want to retrieve the values that we set. Okay, and each time we want a keyframe, so we should have a list, and we say a list of keyframes, and we call it frames or keys equals to new list of keyframe, basically. Okay, and move this guy. Ouch, what did I do? Okay, move this guy down, equals to new mission of keys dot to array, and that will work. Okay, now we want a new array, so we call byte array, and we call it key buffer equals to sub array of the buffer with the starting index of 32, and the length now is our buffer, that length minus 32. Why I'm using 32? Because the arrays are indexed of 0, so 0 to 31 is our start. Okay, now here let's comment the value equals to, if I get this guy, yeah, it's the first element. Okay, then we have in tangent, then we have out tangent, then we have our mode, and then we have our time. Okay, so for the first element, we could say I multiplied by, well, for the first element, actually, it's 0 to 31. Then it's 32 to 63. Then it's 64, not 64, to 95. It's 96 to plus 31, 27. It's 128 to 159, and that's 160. Okay, because we started with 0. Now for the next iteration, it's 160. So basically it's I multiplied by 160 as the start. So start equals to that, plus 0, the length equals to 32. Okay, this guy is I multiplied by 160 plus 32, and the length equals to, again, 32. I multiplied by 160 plus that, the length equals to 32, and I multiplied by 160 plus 96, the length equals to 32, and I multiplied by 160 plus 1, that equals to 32. So let's add it. We say a byte array, and we call it value buffer equals to sub array of the key buffer this time we started with I multiplied 160 plus 0, that is exactly that, and the length is 32. So we copy it, paste it, it's in tangent buffer plus 32, and it is out tangent buffer equals to plus 64. This is mode buffer. Mode buffer equals to that plus 96. I said plus. And finally our time equals to that plus 128. Cool. Okay, at the end now we want our stuff, so float value equals to float of our value buffer. Okay, float in tangent equals to float of our in tangent buffer. Float out tangent equals to float of our out tangent buffer. Then we say int, no, actually I want the keyframe dot, let's say k, and then say k dot tangent mode. Okay, int mode equals to int of the mode buffer. You will see if the int works. Then time is a float, so float time equals to float of time buffer. After that we want a keyframe, we call it key equals to new keyframe, and it accepts time in tangent and out tangent. Interesting. So we have time, we have value, we have in tangent, and we have our out tangent. At that we say key dot tangent mode equals to mode. Nice. Then we say keys dot add our key. There we go, guys. We have our conversion. So what we did first, we get the values, blah blah blah, we put them inside an array. Before array we have the size. So we first have the size of keys, then for each key we add them inside array. Here the order is important. And now that I have the class, so I can replace these guys. No? Bam. Boom. Blah. I'm out of sounds. Okay, the last one. Okay, so we put them in order and we read them back in order. To read them back in order, we are first getting the keys, the array buffer size, and that is a 32-bit int. So we say array size equals to that. Then we want the key buffers, because we know the first 32 bits are the key length. So we pass it and we get the rest. And then we loop through that array size and we get the buffers. Then we convert them to values. Then create a keyframe. Then we make the tangent mode on that keyframe. And then we add it to the key list. And finally, we create an animation curve with the list of key arrays to actually convert that list to an array, and we return the curve. Okay? Cool. Now, I can say, chop this and paste it here. I shouldn't do that like that. I need this part. So this is our value buffer. Paste it here. Then this is our intangent. Paste it here. And we can get rid of these guys. I could put this to float blah blah here, but I want to make it readable. Also, this is an extension method. As you saw, it's being used inside cryptography. I think I added it to the list by now, but we make it public so we can access it outside of here. Basically, when you use this inside params as your first parameter here, you are generating an extension method. You are defining the type of the method here, and here we are defining a type of an array for a generic array. Okay, so any type of array that we send in, we can get the copy of our start index with the length, just like this. So we get a sub array of an array. Okay, so I will chop it. I will create another class, and I will call it extension methods or extensions. Okay, and I will add it here. And yeah. So what is your problem now? Seriously, you need to be inside the class. So public static class extensions, boom, boom, and now it will behave. Okay, but take a look at here. We don't have it now. So, should it be static here? Yeah, it should be static here. Then why can't I see it here? I know. Buffer dot sub array, and we just need this part. Ouch. Delete. That will work. Haha. Cool. So buffer dot sub array, and I was wondering why it was looking like this. So basically this is how you get this not sub extension, extension methods. So in this extension class, and does it really need to be static? No. But now it yells, yeah, now it yells that the static method can't sit. So you make any static class with any name, you make your extension method like this. It will return whatever you want, but the accepting parameter should have this, and then the type that you want this extension method to attach to. So here, for example, I want to attach it to any type of array here, and because buffer is a byte array, now we can call that method on it. Now if we want any parameters like here, we add it at the rest of it, and you can see that I'm using them. Okay, so here we say key buffer dot that, bam, key buffer dot that, key buffer dot that, no, here, key buffer dot that, and I will add tons of extension methods later. That is why I made our own class here. But basically now we are golden. Now this is one way of making getting the subarray. But if you want to deep clone this subarray, I will add another extension method. So public static, and it returns a type generic of an array, and we call it subarray deep clone. And yeah, so again, this means that we want to work on extension method of some type. The type is a generic array, and we call it data, int index, and int length. Okay, now here we say t array. I forgot something. This is generic, so we need to assign the t here. Okay, t array, we say array copy equals to new t of the size length. Now we say array dot copy the data index into array copy 0 length. Well, this is almost like this part, and then after that we want a using. So using memory stream inside system IO, we call it ms equals to new memory stream. Then we say var buffer equals to new no, not buffer, come on, binary formatter equals to new binary formatter. If I find it somewhere, binary formatter, and that then we say binary formatter dot serialize our ms memory stream with the array copy. Then we say memory stream dot position equals to 0. Then we return, we typecast to the t array of binary formatter dot deserialize the memory stream. So this is a deep clone copy of our stuff. Now here I can replace this guy with our, data dot sub array of index and length. So we can completely use our own extension method inside another extension method. Because if you compare the first part of the code, we were doing this 2 times. So why? We can replace it with this. Okay, so this is subarray deep clone if by any chance you need it. I'm not sure. Okay. So that is our converter. Okay, we convert different things to byte array and we get them back from byte array. Next episode I will work on my values. Until that episode, have fun everyone. Bye bye.